A very good afternoon to everyone. Firstly, let me thank SilTerra leadership and management team for the invitation. In my past life, I was responsible for 7,000 employees, 6 world-class fabs. All of them were automotive fabs. We were running parts for automotive under the hood, above the hood. And I also was responsible for a $2.5 billion revenue site with P&L responsibilities. But I left all that in early 2013 to start our own technology and semiconductor startups. And today, I'm going to share some of those things that we've been doing for the last 6 years. Today's talk is on mobility. And mobility is about smartphones, wearables, portable healthcare, point-of-care diagnostics. It's all about miniaturization, portability, longer battery life. Everybody needs more data, faster processing, and also the next modes of transportation. Mobility is going to take a totally different dimension in the next 50 years. In 50 years from today, you'll have robots and cyborgs doing most of our jobs, which will leave some of us to go travel outside of planet Earth. And you will have mankind colonizing Mars and elsewhere in the next 50 years. That capability is there even in the next 30 years. 40% of the world's population will be telecommuting, working from wherever they are. And you have quantum devices, quantum sensors, which can medically diagnose you non-invasively. But behind all these capabilities and wonderful products, what is the key thing that drives and fuels this innovation? It is semiconductor chips, and the wafer fab is in the heart of semiconductor. Without semiconductor and the progress it has done, a lot of things that you see today and what's going to happen in the next 50 years is not going to be there. And broadly speaking, there are 2 types of emerging technologies. The world knows a lot about the mainstream, bleeding-edge digital technologies. The microprocessors, the microcontrollers, the graphics. This is driven by mainstream technologies. You will need to spend US $10 to $20 billion to build one fab that can do 7 nanometer to 14 nanometer. Emerging niche technologies that you can do today in Malaysia. You can build these chips in SilTerra. So this can be done on 8-inch fabs, 200 mm fabs. So what is special about these technologies? You don't need 10 to $20 billion. It's a lot of money. SilTerra is a lot of money, right? But it's not 10 to $20 billion. It takes about 10 to 15 years to develop these technologies. And that's a pretty long time. For this type of technologies, you have the top research institutes in the world, the top engineering universities in the world, developing this process without the pressure of commercialization, with a lot of money coming from their governments. This is a space that IGSS Ventures plays. So we have partners, trusted partners in Singapore, in US, in UK, in Malaysia, obviously, very important partner in Malaysia, and also in China. So this technology produces chips for autonomous and electric vehicles, the next generation. Artificial intelligence, which Industry 4.0 requires. 5G infrastructure, Internet of Things. Next generation sensors, quantum sensors, everything that is emerging will need chips from these technologies. These technologies links 2 separate semiconductor worlds. On the left-hand side, you have the compound semiconductor world. You do not have any compound fabs in Malaysia or in most parts of the world. Compound has superior material properties that silicon can't smell for certain applications. On the right-hand side, you have silicon semiconductor, which produces more than 90% of all our semiconductor needs. Silicon photonics. The photonics comes from the compound world. Silicon, obviously, you know where it comes from, right? That's the link. So here, by having these technologies, you have the best of both worlds, right? You have the superior properties of the compound world, plus the cost competitiveness of the silicon world and the super large ecosystem that's already there in the world. Chips from the gallium nitride and silicon is going to go into all these wonderful applications. So today, we have customers who are working on what they call as quantum sensors made from gallium nitride on silicon. So these sensors can diagnose a medical problem non-invasively. Gallium nitride power management in the next generation automotive and electric cars. In 10 to 12 years, all the largest automobile companies in the world would be almost producing just electric cars. Silicon photonics basically moves data at the speed of light. In the past, data used to move at the speed of electricity. And if you use pure compound products like indium phosphide, data can move at the speed of light, but it's super expensive. Now with silicon photonics, you're combining the best of the silicon world and the beauty of the photonics world. So now you move data at the speed of light, but it's very affordable. It can be done in SilTerra. It can be done in fabs, 8-inch silicon fabs. While indium phosphide, you've got to do it in very small 2, 4-inch fabs, super manual, super difficult. And once you get into silicon photonics, the whole scalability improves from 2-inch all the way to 12-inch. The integration becomes very high. Cost becomes a fraction, right? And the production capability to produce silicon photonics is now suddenly becomes 1000x manifold. Today, we have been working on silicon photonics within IGSS Ventures. We have one subsidiary which is called Compound Tech. We've been working on silicon photonics for the last 2 years. And in the last 18 months, we have attracted 12 commercial customers globally, from the multi-billion-dollar automotive guys in Japan to very exciting startups. And we also have 19 research institutes that has designed their products in our technology platforms, which is currently running in SilTerra. So that all happened in the last 15 to 18 months. So out of the 12 commercial customers we have today, about half of them come from the datacom telecom world, working on chips for the next generation data centers, which is going to be important for 5G infrastructure, for IoT, and etc. The balance half comes from very exciting fields. We have 2 customers from artificial intelligence, one from quantum computing, one more customer from biomedical, okay, working on chips and the procedure that will shorten the whole diagnosis in the emergency rooms. We also have customers working on LiDAR, a multi-billion-dollar Japanese giant for automotive industry. This wafer, this chip is now running in SilTerra. So to summarize, the technologies that we play links 2 very important semiconductor worlds. I firmly believe that this is going to be the future. How we take the superior properties of the compound semiconductor and integrate that with the silicon semiconductor, which is super cheap, super scalable. These technologies will produce systems, chips that is 80% smaller, 70% lighter, high integration, super scalability, utilizes the wide silicon ecosystem that we have globally. And our grandkids will have flying cars in their garages. They'll be working on quantum computers, not the computers that we are working on today.